Says find the sum. So make sure on a quiz or a test you're circling that to remind yourself, oh yeah, it's got to be geometric or telescoping. Geometric means numbers to the nth power. I see that. And it's necessary for you to split this up into two separate sums. 5 to the n, 4 to the n. And notice how I'm leaving off the n equal 1 to infinity. That's totally fine to do. I can see this is the number 1/4 to the n, and this is the number 5/4 to the n. Wait a minute. This definitely is a divergent geometric because you can see that r is equal to 5/4. So since I have converge minus diverge, the whole thing diverges. Okay, so let's do this one again. I want to emphasize that on a quiz or a test, I need to see what your S sub n is. So first steps here are to figure out, to use partial fractions to figure out the A and the B. N plus 3. Okay, so I get 2 is equal to A times n plus 3 plus B n plus 1. So if I let n equal -1, that's gone. So I get 2 is equal to 2a. Oh, a is 1. All right, so now let's let n equal -3. So I get a 2 is equal to a -2b, and so b is -1. Whoops, b is -1. So again, you have to plug it back into here. So I'm going to take liberties and make room. Okay, so I'm going to put this is the new sum is the A, 1 over n plus 1, subtract the B, 1 over n plus 3. Okay, so do not separate the sum into two separate ones to try to figure out what they do. You need to write out since it says find the sum, it's not geometric, so you're expecting telescoping. So you have to just remind yourself of that. I'm expecting a telescoping sum, so that means I have to write out what the S sub n is. So S sub n, so I'm going to plug in n equal 1. So I get 1/2, plug in n equal 1 minus 1/4. Now I'm going to plug in n equal 2. 1/3 minus 1/5. And I'm going to plug in n equal 3. So I get 1/4 minus 1 over 6 plus, and I'm just going to write one more down, plug in n equal 4 just so you really see the pattern. 1/5 minus 1/7. Okay, so there's a whole bunch of dots going on. So let's just start to investigate what the canceling pattern is. 1/2 sticks around. -1/4. Look at that. It's the last one in this group. Skip a group. First one in this group. This 1/3 sticks around. Last one in this group. Skip a group. First one in this group. Okay, so we need to see how that pattern continues. Mathematicians love patterns. Okay, so let's write out the last term. So that's the nth term. So 1 over n plus 1 minus 1 over n plus 3. And if I was to write out the n minus first term, that'd be plugging in n minus 1 into here, 1 over n minus 1 over n plus 2. And I'm going to do one more. I'm going to put the n minus second term in here. Oops, trying to get rid of those dots. Okay, so if I put in n minus 2, I get 1 over n minus 1 minus 1 over n plus 1. And there's a whole bunch of dots in there. So the reason I did so many terms at the end is because I recognize there's 2 terms at the beginning. There's going to be 2 terms at the end. So let's see if I can figure out some canceling. Look at that. Last one in this group, skip a group, first one in this group. Last one in this group. Oops, hold on. No, can't do that one. Can't do that one. What can I do? No, there's no, wait. This one back here. Last one in this group, skip a group, first one in this group. And then this one would go back here. So what am I left with for my S sub n's? I've got the 1/2 and the 1/3. And so what I'm going to have left are this one and this one, right? Because all these other guys will cancel. So I get a minus 1 over n plus 2, minus a 1 over n plus 3. And then let me make some room up here. So I'm going to give full credit on a quiz or a test for you writing out, oh, I know what the S sub n is, 2 terms at the beginning, 2 terms at the end. Then the sum is equal to the limit as n goes to infinity of my S sub n. That's 1/2 plus 1/3, and that's a fine answer.